Hello and welcome. This is Dramani Online Mathematics. Before I start, let me comment Dr. Frimpong Sylvester Ali, my PDE and OD lecturer at University of Education. May God bless him. He did very well. He impacted a lot in our life. Yes. So let's start with the partial differential equation. Already you have learned something about the ODE, that's ordinary differential equation. For the ODE, the only thing was that we said that the ODE is only having one independent variable and its derivative, okay? But when it comes to the PDE is having more than one independent variable. So you can have X, you can have Y, we can have Z. Is that okay? So the independent variable is what you are making or putting the emphasis on. The ODE have only one, but the PDE has more than one, okay? So that's what we call partial differential equation. Partial means being biased of something. Okay, good. So now let's look at the differential. Partial differential equation is an equation involving a function u of several variables. So the function u here becomes a dependent. Is that okay? And the independents are the several variables we are talking about, and its partial derivative. Is that okay? Good. Now let's look at the notations of partial differential equations. We are going to look at the notation of partial differential equation, PDE. Now, for partial differential equation, we use delta. Okay, we don't use d like the ordinary differential equation where we were using the y, the x, and those as no. Here we use, let's say, delta u delta x. Now, this is also written as u subscript x. This is the dependent, okay, with respect to the x. So this is partial derivative of what? X. So we can also have, so that is, let's name it I. We can have delta u delta y. So that is going to be u subscript what? Y. U subscript y. So this means partial derivative with respect to y. Delta u delta y can also be written as this. Remember the OD, the ordinary differential equation. When it's second order, you can write this as the square y, the x squared, right? So here too, the same thing. For second order, you can have delta square u delta x squared. Now, if I'm to write this one in the form like this, it becomes u x. Means that you have taken the first and second derivative, partial derivative of the function. Then we can also have delta square u delta x delta y. What does this one mean? It means that we have u x y. What it means is that first you take the partial derivative of x, then come and take partial derivative of what? Y. So that is the notation of it. Is that okay? Good. Now let's look at some examples of partial derivatives. So now let's look at the examples. Delta u, so for example, delta u delta x plus x delta u delta y equals 0. So this is a partial derivative, okay? So we can write this one as delta u delta x is the same as u subscript x. Is that okay? Plus x here, then u subscript y is equals to what? 0. So this is the same as that. Then also here will be what? U multiplied by u subscript x. This u is already here. Then this delta square u means that u subscript x plus 3 u subscript xy plus x u subscript what? Y equals sine x. Then this one, You can change them. Is that okay? So try this and see. Then let's look at, and the number 3 too, you can also change it. Let's look at the number 5. Now you could see that this is delta U delta S all squared. This is a degree or power. This is not an order like this. This is the second order. This is not second order, but this is power 2. So here if I'm writing, it becomes U subscript X squared like this. And this becomes U subscript Y squared equals 1. So you should know the difference. Is that okay? Good. Okay, now let's look at order of derivative. Okay, the order of derivative. How these things arrange, the derivative is arranged. For continuous function, the order of differential does not matter. Okay, so you know continuous function, when there's no loop or breakages of anywhere, it's always like this. It does not matter. So let's say if I have U subscript X, Y, Z is the same as differentiating partially as X, Z, Y. The same as differentiating it partially as Z, Y, X. Okay. Now, what is partial differential equation? How do we even differentiate it? That is the question. I'll give you the definition, but how do we differentiate it? It's like this. You see, let's assume that I have U equals 3x plus y. And I'm to differentiate this one partially with respect to x. What it means is that I'm going to treat anything that is not x as constant. And you and I know that when you're differentiating constant, it's 0. You understand that? You and I know that when I differentiate constant, it's 0. So if that is the case, I will differentiate this one. If I differentiate, this will give me 3. This y will be what? 0. Okay. So that is what the partial means. So let's see how we can try the example. If u equals s cubed y squared z, then find I. So you just want to prove to see if this one actually true. So let's start with the I. You should find u, x, y, z. So let's start. You say u is equals to s cubed y squared z. So first, we are differentiating with respect to x first. So partially, the y and z here become constants. So we differentiate s cubed. If we differentiate s cubed, what do you get? You get 3x squared. Then you maintain our constants. Is that okay? Good. Then from here, we are differentiating with respect to what? Y. So we are going to have y. So u, x, y. Now, is this one we are differentiating, not this one anymore, because already have the ux there. So we are adding the y to it. And this will give us, if I differentiate y squared, that will give me 2y. Okay, but the 2, there's 3 here. That will be 6x squared y z. Now, y, x, x, y, z equals, now if I differentiate z, that will give me 1. So I have 6x squared y. So that is the I. Now let's look at the II. So the II, we have, if you look at this one too is going to give us, first we are differentiating with respect to x. That one we have done it already. So that 3x squared y squared z. Second, with respect to z, so y ux z. If I differentiate z, that will give me 1. So still have 3x squared y squared. Then last, we differentiate this with respect to y. If I differentiate, this will give me 2y. 2 times 3 is 6. So 6x squared y. So if you compare this one to this, you see they are the same. Now let's look at the last one. The last one, if you do it, you get the same thing. So that shows that for continuous function, the order does not matter. The arrangement of it does not matter. So if somebody decides, let's say a question like this is given, and you have to differentiate this one, and someone decides to start with x, then move to y, then move to z, and someone also decides to start with x, move to z, and move to y, and someone decides to start with z, move to y, move to x, you all get the same what? Answer. Is that okay? Very good. So now let's move on to the next topic.